All right, so now we're going to do some examples. We're going to be given a group of sets here. So given the set A equals 1 to 10, B equals X such that X is even, C equals X such that X is an element of Z, which is integers, and D equals X such that X is a natural number, X is greater than 10, and X is less than 20. So, if we start here, we want to know, is A a subset of B? Well, B contains all even numbers, and there are some odd numbers here in A. So the answer to that is false. Is B a subset of C? Well, C is all integers, and B is all even numbers. So that is true. Is C a subset of D? C is not a subset of D. However, if we were to flip that around, D is a subset of C, because in this case, this is 11 through 19 for the set D. So those are all integers. However, that is not the question being asked. Is C a subset of D? That answer is false. Now, we want to look at the union of A and D. And what set is that going to give us? So A is 1 through 10, D is 11 through 19. So we're going to do, this is going to take a moment. Well, actually, let's speed it up a little bit. We're going to do this. I'm just going to use a nice little copy paste. Is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we know that it's 11 through 19, so we can just copy these again and put ones behind them. So 11, 12, 13, 14, 15, 16, 17, 18, 19. There's our complete set. Of course, you could do 1, 2, 3, ... 19, but I want to give the full contents here. The union now of B with D. This time around, we are looking at all even numbers between 11 and 19. So that's going to be 12, 14, 16, 18. Now, the intersection of A and D. A, again, 1 through 10. D is 11 through 19. There is no intersection. So, we can write this as an empty set. You can write the null set symbol. I will accept either one. I don't feel like copying and pasting the null set symbol, so I'll just use the curly braces. Keep those empty. Now we do the intersection of B and D, and I realize I need to come back up here because I did a dumb. So we're talking about the union. So what is in both B and D? It is going to be all even numbers as well as 11, 13, 15, 17, and 19. So let's come back up here and correct ourselves. So we do 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, comma, 16, 17, comma, 18, 19, and then 20, 22, 24, 26, and so on and so forth. So that is our correct union of B with D. And you can write this as all even numbers plus 11, 13, 15, 17, and 19 if you wish. This is just another longer way to write it. So now let's come back here to the union of B and D, or the intersection of B and D, rather. So the intersection of B and D is things that are in both of these sets. And this is going to be even numbers between 11 and 19. So 12, 14, 16, 18. Now we look at B's complement. B is even numbers. It's tempting to say that B's complement is all odd numbers. This is not what we're looking for. Rather, we're going to do x such that x is less than or equal to 0, or x. Okay, how do we write this? So we're talking about all non-even real numbers. So let's write it that simple. You could just write it like this. It's not entirely kosher, but as long as you show that you understand how to get a fully factual complement, it's okay for me. So if B is even, its complement is all non-even real numbers. So D and D's complement as an intersection. Again, these are mutually exclusive, so this is going to be the null set. You can write your no symbol, you can do empty braces. It's up to you. Our last two examples here, these are going to be your first questions on your assignment for this material. So we're given a set in this notation, and we want to write its contents. So give the full contents of the set E, which equals x, such that x is a natural number, x is prime, and x is less than 10. Now, a little bit of logic. All prime numbers are natural numbers. So we don't need to think about this one. So all we can really focus on is x is prime and x is less than 10. So what are our prime numbers? From 1 to 10, 1 is not a prime number because it must have two factors, not one factor. 1 is only one factor, 1 times 1. So 2 is our first prime number. It is only divisible by 1 and 2. 3 is only divisible by 1 and 3. Is 4 a prime number? No, because it's divisible by 2. Is 5 a prime number? Yes, it's divisible by 1 and 5. 6 is divisible by 2 and 3, so it is not prime. 7, divisible only by itself and 1. Now, is 8 prime? No, it's also divisible by 2 and 4. What about 9? No, 9 is also divisible by 3. So our set for E is 2, 3, 5, 7. Then give the full contents of the set F, which equals x, such that x is a perfect square and x is less than 50. Oh, I wrote that wrong. I wrote it wrong again. All right. So we're looking at perfect squares under 50. A perfect square is always going to be a positive number. So our perfect squares, is 1 a perfect square? Yes, 1 times 1 is 1. 1 is, 2 is not, 3 is not, 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And 7 times 7 is 49. And that'll finish out our set. So our perfect squares under 50 are the squares of 1, 2, 3, 4, 5, 6, and 7. And so this should help you get started. A lot of these questions are going to be very similar to the ones you see on your homework. So best of luck. You'll find these examples posted on Canvas. So next time when we come back, we're going to go back to programming. We're going to be talking about built-in functions. I'm going to go over some examples of ones that you'll need, as well as show you where to find more, because I'm not going to cover all the ones that you need. You're going to have to do some digging of your own. So, with all that being said, oh, wait a minute. Let's correct our notation here. F equals. So with all that being said, see y'all next time. Stay tuned.